Okay, so let's try the next coding exercise. So open the leetcode.com and go to the program section. And in the search question, search pre-order and hit enter. So there is a question number 144, binary tree pre-order traversal. It's also come under the easy category. So in the last question, what we did is what we did the binary tree in order traversal. So to traverse the tree, so tree means who has the left node and the right node as well. So to traverse the tree, there are three methods available. One is the in order, one is the pre-order, one is the post order. In the last video, we have covered the in order. So in this video, we cover the pre-order traversal. And if you know one method, then to write the code either using the recursion or either using the iterative approach, everything is going to remain same. A very minute modification, otherwise just a copy paste of the code. Okay, so let's try to see what is binary tree pre-order traversal. So let's go to the whiteboard. So let's suppose we have some tree is given. So in the in order, so when we see the in the in order we have to go inside. All right, so if we go from inside, then we have to print first left node, then root, and then right node. All right, so how we remember the in order traversal? So first is left node, then root node, then right node. Okay, then we have the pre. So if you see the term pre means whoever is coming first. So first is coming like a root. So root is coming. So first we have to print root, then we have to print left one, then we have to print the right one. Okay, so this is the the pre-order traversal in which we have to print first root, then we have to print left, then we have to print right. So if we consider this tree, what could be the output? So first is the root. So 15 is, so first element should be 15. Then we have to process the left tree. So in the left tree, so if we consider this as a sub problem, this as a sub problem, all right, then we come here. So now 10 is a root. So if we apply pre-order traversal in this area itself, then first we have to print 10. Then we have to go to the left. All right. So then this is a sub problem. So if this is a sub problem, then if there is a root, we have to print 4. Then we have to come to right, then 12. Then everything is finished here. Then we have to process the right tree as well, right subtree. So first 22, then left 18, then 24. So this is the a pre-order traversal. So how we are going to approach? So we will again try this question using the two approaches. One is the recursion. Recursion is very easy. We have to just call the same function again and again. So in the recursion, what we will do, so what we have to do is we have to first print the root node, right? So what we can do is we will, because root node is given, we will start from the root node. In the output we are going to append our root node, all right, because first root node should be there. Then we know we have to call the left subtree. So what we will do, we will call the same function on this subtree. So we will assume this will give some output, and whatever the output it will give, we will append after the 15. Then we will call the same function on the right subtree, and whatever the output it will give, we are going to append after that. All right. So let's try to write the recursive solution within the Python. So let's go to the here. So first we are going to write the recursive solution. So let's go. So this is the recursive approach, and we know first we have to print root, then we have to print right, then we have to print, sorry, then root, left, and then right, which is the pre-order. Okay. So we need some array, because we need to return some list. So that's why we need some array, or you can say list, right? And we have to return that output, which is perfectly fine, right? So what we can do is we will call some function which is going to process our actual logic. So self dot pre-order, we will create some function, right? And which is going to accept our root and the output, root, because we have to process the tree, and root is given, so we will pass the root and the output. Now we will write this function. So we are going to write this function. So def self root and output, because it is taking three elements. One is the self, one is the root, one is the output. Okay, now we have to write only this function, that's it. So how we are going to write is, so first root is given. So root is given. What we have to do? So if root is given, all right. So if root is given, if root, because there should be empty tree. So we will check if root. Then what we have to do in the output? In the output, we are going to append root dot value, because in the output we don't need to put the node, we need to put the value. So what is the value? Like self dot val. So there are three variables uh, associated with this particular node. One is a left pointer, one is a right pointer, one is the value. So we need the value. So we are going to put the output dot append root dot value, which is perfectly fine. Now in the output we have appended 15. So in the recursive approach, we will just call the same function. We are going to call the same function on the left tree. So we are going to call the same function. So self dot preorder. So we are going to call the same function on the left tree, the root dot left. So root dot left, root means 15. 15 dot left means this subtree, which means this subtree. We are going to call the same function on this subtree, root dot left, and we are also going to pass the output, because this function needs two variables, root and output. Okay. Then once this is done, then we have to call the same function on the right subtree, on the right subtree. Right. So self dot preorder root dot right output. That's it. Our solution finish. So how it's going to process? So we took some output. We are calling this function. So in the function, first is root. Root is 15. 15 is done. Then we are going to append 15 in our output. So here 15 will come. So here 15 will come. So let's suppose here 15 will come. Right. Then what will happen? We are calling the pre-order on the left hand side. So we are calling the pre-order on the left hand side. So on the left hand side, so if root dot left go into this root variable, so now root is 10. So if there is a root, then we are going to append 10 into our output. So now the 10 will come here. So now the 10 will come here. Now we are calling the same function again on the left hand side of that. So now the 10th left side is 4. So now the root become 4. So if there is a root, then we are going to append. And then we are going to call on the left hand side, but there is nothing on the left hand side. So if there is a no root, then it is just going to pass if there is no root. So then we are calling the same function on the right hand side. So we are calling the same function on the right hand side. So there is a nothing on the right hand side, then we are going to pass. Then there is a one more thing, that on the 10th of right hand side, so which is 12, and then we are going to append the 12. So this is the recursive approach. Recursive approach is very simple. We have to just assume the base case, and we have to call the, we don't need to worry about, we will just assume that our left will give the output and the right will give the output. We are just going to assume, and we have to put the base case. So this is our base case. Like if there is a root, then we have to append our value. That's it. And rest automatically it will give. So let's try to run it. So our solution has been accepted. So let's try to submit it. So our solution perfectly run fine. All right. So which is fine. And in the pre-order, we know, like we just, because in the pre-order we need first left, so we put first left and then root and then right. So just a little modification. All right. Now let's try with the iterative approach. So we should not like call the same function again and again. We have to try the iterative approach. We have to try the iterative approach. So how we are going to perform the iterative approach? So in the iterative approach, what we can do, because if we are traversing, if we are traversing something, all right, and we need to, like, first we need to print root. Okay, we are on here, we can print the root, right? Then we have to go the left, so we have to process the left. But if we go here, then we are like our the right hand side tree pointer like has been removed, because we already done with the right. So we have to store somewhere, like these elements. So to store these things, what we can do is we can take a stack as an extra memory. So we will take a stack as an extra memory, right? So what we will do is, okay, so we have to take the stack as an extra memory to store the element. Okay, and then we are going to run some loop while true. And in the stack, what we can do is, Okay, so in the stack, what we can do is, in starting, whatever the root element, we can insert the 15 here. That is the root element. So in the stack, what we can do is, even before, if root, so if there is a root, so if root is given, or you can say if root is none, then just return. Otherwise we can go, or even you don't need to mention root is none. What we can do is, so if root, then what we can do is stack dot append root. So we are going to append 15, that's it. So if there is a root, then we are going to append, then we are going to run the while loops, and within the while loop, what we can do is, so we will check. So we will run this while loop until our stack will not go, until there is a some element in the stack, until length of stack is greater than 0. So first we need to print 15, and 15 is in the stack. We will pop that element. So let's pop the element. So stack dot pop. All right. So we have popped the element. If we pop the element, we need to append that element in our output. So we pop from here. We pop from here. So we get the node. So we need to append into our output. So output dot append and node dot value, because we need to print the value. So node is a full node which contains three values, val or a left and right, but we need only val. Okay, which is perfectly fine. Then what next? Then we have to, like, what we have to do is, we have to now go on the left hand side direction, and then we have to go to the right hand side direction. So what is the property of stack? Stack is like, it's not a first in first out, is it first in last out? So first we need to print the left hand side, and then we need to print the, so first we need to print the left hand side, and then we need to print the right hand side. All right. And if we go, because we already pop 15, so we need to store both the pointers, left pointer and the right pointer. Otherwise, we are going to miss something. So, okay, so tell me which pointer we are going to store first, whether the left pointer or right pointer. So let's suppose if we store first left pointer, so let's store first 10 here. And then we are going to store the 22, because we need to store both the pointer, right? And what is the stack property? Stack property is uh, first in last out, or last in first out. So last in is 22, so it is going to remove first. So if it is going to remove first, then our sequence is 15 and then right, but we need first 15 and then 10. So because of this reason, what we can do is, we are going to insert first left hand side, sorry, first right hand side, and then we are going to insert the left hand side within the stack. So we already popped the 15. So we will check if they, because there should be some condition, like there could be no element on the right hand side. So if root dot right, so if there is anything on the right, what we can do is stack dot append root dot right. So if there is anything, yes, there is anything, so we are going to append into the stack, which is perfectly fine. If there is a no element on the right side, then what we have to do? So if root dot left, so if there is a left, like if there's something on the left hand side, then we have to append stack dot append root dot left. So we are going to append 10 as well. All right. Then it is going to, like, run the loop. Then we will again check. So while loop will again, so if the stack is empty, no, if the stack length is greater than 0, yes, the stack length is 2 and it is greater than 0. So what we are going to do is, we are going to pop the top element. So we are going to pop, so 10 is going to pop, and we are going to append here in our output array. Okay, so if stack is going to append, now we will check 10. So whatever the we are, like, not root, so node dot right, so here should be node. So node, here should be node, because like whatever the element we are popping, so here we pop 15, so we are checking for that element, so that is a node. Or so node dot right, node dot left, fine. So we will check if there is a node dot write. Yes, there is a node dot write. So what we can do is we are going to insert into the stack. If there is a node dot left, yes, if there is a node dot left, what we are going to do, we are going to insert into the stack, which is fine, perfectly fine. Then we are going to again go above. So is the length of the stack is greater than 0? Yes, the length of stack is greater than 0. If the length of stack is greater than 0, we are going to pop and then we are going to append. So we are going to pop. So pop will, the last element is going to pop. So 4 come here and we are going to remove from here. Okay. Then if node dot right. So is there anything on the right of the 4? No. Is there anything on the left of the 4? No, which is perfectly fine. Then it's like the loop will go run again. So if the length of stack is still greater than 0, yes, then we are going to again pop. So what is going to now pop? So 12 is going to pop. So now the 12 is going to pop. All right. So 12 is going to pop. Now we will check, is there any right hand side on the 12? No. If there is a left hand side of the 12? No. Okay, then again the while loop will say if the length of stack is greater than 0, yes, there is one element, one is greater than 0, then we are going to pop. So 22 is going to pop. If 22 is going to pop, it is going to attach to here. All right. Now we will check if there is a right hand side of the 12. Yes, there is a right hand side, then we are going to append. So 24 is going to append here. If there is any left element on the on that particular node, yes, there is a left element as well. So we are going to pop. Then the loop will run again. So if the length of the stack is greater than 0, yes, then we are going to pop the first element and we are going to append into the output array. Then we will check if there is a left element, right element, no. If there is a left element, no. Then the loop will run again. If the length of the stack is greater than 0, yes, length of the stack is 1 and 1 is greater than 0. Then we are going to pop 24 and we are going to append. So 24 we are going to append. Then we will check if there is a right element on the node. So no, so there are like no right element. So there are no right elements, so it's blank. And is there a left element? No, there is nothing on the left hand side as well. Okay, so now the loop will run again. So now the loop will run again. Now we will check if the length of stack is greater than 0. No, length of the stack is not greater than 0. It is empty. So it means we are done. Then we are going to return the output. That's it. So we have to just make sure like because first we need 15. So we have put but is either we have to put first left hand side or right hand side, because if we put insert 10 first, right, then instead of stack better take q. And if we're taking stack, then first we have to insert 22 and then 10, because it is last in first out. So last, because we need first this element, so we are going to insert at last. So first we insert 22 and then 10. That's why like we put this, like if first we are checking right hand side and then we're appending right hand side, and then we are checking left hand side and then we are appending the left hand side. So let's try to run that solution if it is like correct or wrong. So let's try to submit it. So our solution has been accepted. So let's try to submit. So our solution has ran fine. Okay, so you can also try this question. So because only there within the tree there are only 3 traversal method, and we should know all the 3 methods. And if you know only one now, you can write each and every all the 3 methods. So in the next video, we will do the post order. So post order is also just a ditto copy. Just like we have to just check, okay, first we have either we did first right or left or root, whatever we want, we are going to modify our code accordingly. Otherwise, everything is going to remain same. So that's it at the end of the video. Thank you.